code's ready to go. Let's see what we got. So I'm going to open up Eclipse. Alright, so what do we got here? Normal forms. If I go to... I wonder how I can see, like, let's see, Windows, Show View, and like Other View. You have it like a Get View. Repository, Staging. One of these two, Staging or Repository. Let's see Repository. So let's see, Remote. Yeah, I like seeing like the source tree version of this. Yeah, here we go. Not test stream, but planning. If I go to the branches area, I just fetch. I'm like 2 behind on my... Yeah, let's check this one out. Yeah. What can I do? Rebase? Is it rebase? Reset current branch to this commit. I like it. Cool. What's uncommitted? If I double click it, what happens? If I go to team, yeah, I don't know about all this. I think I'm just gonna grab exactly what I have on the server. So let's do that. Where am I at here? I'm gonna discard these changes. Okay. And discard these changes. Okay, and then hopefully here you'll tell me stuff has changed. I have all the comments, everything's looking good. If I run the test, everything should be green. Should have my complicated Boolean logic. Yep. Alright, cool. So that looks pretty good. Let me just look at this. I just wanted to see normal forms. Alright, let me just read what I did here. The initial implementations, that's nice. The normal forms tests, yep, some complex Boolean expression. Testing exposed some issues, spent more time and tests with the test and realized that the CNFs and DNFs were not coming out as simplified as I would like. Using default simplify methods, I created some code to correct this, but it's incomplete. I also like to test null cases. Alright. Comment the code and implement more simplifying ones. Awesome. Class ready. Let me just do one more thing, and that's check for nulls. Okay. Let's do it. Assert equals false if you put in null. Assert equals false if we put a new conjunction null. I haven't tried that. Didn't think you could do just a basic empty conjunction, so that's another thing I gotta check. Arg. Alright, well, good to know now, I guess. What other things can I make? Let's go ahead and make empty stuff. Test empty objects. And so we have a conjunction. Empty conjunction equals new conjunction. Disjunction, empty disjunction equals new disjunction. Let's just do all of them. Predication. Guess you can't do that, right? We can do, what can we do? Predication, predicate in terms, predicate in terms. Alright. So we got new conjunction, new disjunction. Shoot, let me grab a file from my computer at work right quick. Team viewer. I need this one. Alright, man, everyone wants to open that in Edge. I don't want to open up in Edge. Let's open it up in, yeah, Chrome. I don't see anything happening. Yeah, there we go. More apps. Find an app. This app. Please open it up with that. Alright, so I need to check conjunction, disjunction, negated literal, negation, and predication. There's, well, predication I can't do. Negation and negated literal I think I can do. Negated literal and predication are kind of similar. Alright, anyway, I'll figure it out. Empty negation equals new negation. Okay, so we have a conjunction, a disjunction, and a negation. Let's go. So instead of Yeah, okay, null. I don't know what happened if you do null, new, no, empty conjunction, empty disjunction, empty disjunction, conjunction, literal. Nope, it was a negation or something. Let's go, let's go. Empty negation. Alright, so let's do is literal. Oh my gosh, everything failed. Is there a problem? I don't know why everything failed. I can't figure it out. I think those are the only lines I could have added. Let's see. I don't know. Basically, you're saying there's an exception up here somewhere. So, an n-ary Boolean expression requires at least one argument. So, are you telling me something like this? How about that? Okay. Definitely super weird, but seems good enough. Good. Yep, these should fail too. But I don't know what you want from me. Is conjunctive clause test. Oh, it's not is conjunctive clause test, it's just is conjunctive clause. Okay. Let's just test that, see if that worked. Awesome. I think even these will fail. Love it. And finally is DNF. Okay. Now the hard part. I don't even know what this is going to return, so I'm just do a debug on this right quick. Let's just do the empty conjunction. To CNF empty conjunction. Oops, I forgot to say equals. Okay. To CNF empty deep disjunction test equals to CNF. Oh, you can't actually use a negation, right? Empty Cortana, why? You can't do the other one. Alright, so good to know. Let's just break here. I just used you below. Okay. I think I'm gonna just go debug, say yes if it wants me to change the perspective. Find the should I just hit F6, see what happens? Okay. And it just gives me exactly the same thing. F6. Awesome. Alright, so it gives me that and null. So that's what I'm gonna do. I'm gonna just kind of copy these two. Ooh, I forgot to test the null. Well, we'll see what happens. Let's just do 2 CNF, 2 CNF, 2 CNF. I think we're just gonna get the empty conjunction every time. It's ambiguous, so we'll cast it. Let's get the null expression. Like that? Is that good? So now I can just say null expression. Nice, I don't have to cast every time. Null expression. 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 Let's just do null conjunction. Play? Eesh, we have a problem. Yeah, so that's what I better check. Alright, so now I got some nulls up in there. Where's my code? Oh yeah, let's just hit Java. How about now? I see. How about that? Um, I think I'm just gonna have to have checks, cause hmm. Alright, so we're gonna say if is conjunction equals null, or conjunction dot arguments dot get I get 0 equals null. Something like that. So if I hit play, um, yep, let's jump in. So what's my conjunction? And null, of course. Other, yeah. Okay. Let's jump in. So this is not working very well. So conjunctions equal null. Is this gonna crash? Is this gonna crash? Is this gonna crash? That's gonna crash. I understand. I understand. Look, I don't mind that at all, because that is totally standard. All right. So if is CNF If conjunction equals null, return null. If conjunction equals new conjunction, just empty. Expression null. Return null. Let's go ahead and get the empty, well, since I already did it here. Yeah. Good to have, I guess. Null expression, empty conjunction, and for some reason I didn't replace this one. Let's go. Alright, I'm going. Let's do it. To conjunction. If is conjunction or conjunction equals null or conjunction equals empty, this dot empty. Where's my 2CMF? There we go. Empty conjunction. Is that everything? I get it. But how do I check? Alright, so is conjunction equals null, return. Alright, so what I'm missing is, hey, if you got an empty conjunction, that's where I'm kind of screwed, I guess. Expression test, conjunction dot arguments dot get 0. What would you do? I definitely have to put a stop point right here. Then we'd totally jump in. geez. Yeah, I accidentally jumped out. Jump in, over, over. So I'd get null. I feel like if I can just say, hey, if that's null, return it. Now, can't I do that? If conjunction dot arguments dot get 0 is equal. Oh, you can't say. Um, Something like this, maybe. Would this be a good workaround? Um, what do you say? Oh yeah, you gotta check. Let's do that first. If conjunction equals null, return conjunction. First test. Now we're saying if one. Alright, I understand that. So let's go ahead and oh my gosh, how do I just say guess if I cast both of them, it'll be better. Maybe. What would you say? Formula. Oh, I see there is a problem already. I thought formula was a object or a class. If I go to my it's interface, which is okay, right? Let's go back to Java. Let's go back to planning source. Yes, yes. Oh, you don't actually cast like that here. Something like that. Alright, so formula, first argument formula. You're still not going to play nice, huh? That's okay. I jumped in, hit F6. Please open up the perspective. Arguments is an immutable array. Do me a favor. If conjunction argument equal empty conjunction dot arguments, return conjunction. F5, F5. They don't equal. That's okay. It's okay. I'm trying to figure out something. So if I just run this, Alright, so that was a failing edge case that I don't have any control over. Let's see about this one. I'm gonna say the same thing, right? Now, green. Alright, so we got failing edge case, failing edge case. Alright, cool. So that is it. I think I got everything. Alright. So, with that being said, I guess I can try to do my presentation right quick. Presentation doesn't have to be that long, so because we have 2 other people presenting that same day, so it'll be like 20 minutes, I guess. So, alright, I'll give my presentation a little shot. It'll be a little bit of a quick one. So here we go. Hey, my name is Edward Garcia, and today I've been summoned here to create normal forms. Alright, so normal forms is a class full of static functions. And before I even go into what static functions I'll be covering today, I just want to kind of give you an overview of what the logic folder has in our planning project. So last time we covered this stuff. We covered the hash bindings and the list bindings, and so that basically implements the interface bindings, which also implements the interface's substitution and clonable. And so I have everything here color coded. So everything blue is going to be an interface. Everything red here is going to be a final object that you can that can be actually created. And then the green is abstract classes. Okay. So everything I'm doing with is here on the right hand side. And I will be dealing mostly with the formulas and mostly with expressions. We will use the terms a little bit just to initiate some expressions, but that's all. So we have 2 terms, which is a constant or a variable. So expressions can be expressions have expression objects as an abstract class or literal, and if we just keep following this chain down, we have a Boolean expression, which is your basic and or operators, and then we have an n-ary Boolean expression, which actually makes which holds arguments. So it doesn't just have to be it can be a list of arguments that's either a conjunction or a disjunction. And then that being said, if it's a conjunction, it'll be this argument and this argument and, or sorry, this expression and this expression and this expression. If it's a disjunction, it'll be this expression or this expression or this expression. Alright, so that's how that's set up. If we come back up here and come down, we have a literal interface. So a literal interface will be just one thing that holds a value. And so a true or false or not specified value. So the two literals that we have are predication, which is our standard statement in logic. So a predication can be at New Orleans. It could be plain at plain location. It could be all these different things. And then a negated literal is basically a negative of a predication. Yeah. So they both implement literal, and that is our first function of our normal forms. Is you're just checking, hey, is the object we're looking at, is the expression a literal? And so we went over predication, we went over negated literals, conjunctions and disjunctions. The other thing I wanted to mention is negation. So negation is just not something, but it doesn't have to be a literal. It could be not a whole statement, it could be not one literal. The thing that I think throws me off a little bit here is I think you can have a negation of a predication and it not be a negated literal. It'll be rare because I don't think there's any kind of methods where you can actually do that, but I don't know. But typically if you see just a negation, just know that a negation can be an entire expression or an n-ary Boolean expression, or it could just be a one thing like a predication, or it could be a negation of a negation, which would be a double negative. So yeah, these are just things that you had to look out for. So okay, on to what I have to do here. So what I did is created this normal forms. All these functions were specified, and I just had to implement them. So we have is literal, is clause, is conjunctive clause, is disjunctive clause. And so these first 6 are going to just return Boolean expressions, whether it is something or isn't. And then the next 4 actually does some work where it basically changes one expression to a different expression. So that being said, it'd be in a conjunctive normal form or disjunctive normal form. So I think I'm going to kind of just visit this backwards. I think I'm going to do the test first, and then I'm going to do the explanation of the code. So okay, here is the code for the test. First, we just had to start with some terms because you can't have a predication without some terms. So we defined 6 terms here. It's 3 constants, 3 variables, and so when you're initiating these terms, you have to have a type. So these terms could be of type plain, of type cargo, of type box or block, and then they also have to have a name. So that's what this is. We have 3 constants, A, B, C, and 3 variables, X, Y, Z. And then we created a predication for each one. So the predication I'm just using now is just called test, just an arbitrary string. And then the actual constants and variables is constant A, B, C, and variable X, Y, Z. So we have A, B, C, X, Y, Z. Okay. And now we have, since we have now these 6 predications, these predications are the literals. They're the ones that are going to it's your one value that's either a true or false. So we have our literals. The next thing we can do is negate those literals. So each expression has a negate function, so we can just call a.negate, and it returns the negated literal. So I just did that for every one of these literals, and so we have not A, not B, not C, not X, not Y, not Z. Very nice. And then I figured I'd try some of these edge cases. So I made a new null expression. So it's null for, but of type expression. I made a new conjunction with nothing in it, so with null expression. And I've also made a disjunction with the null expression, with only one null expression in it. And I also have a negation with the null expression in it. Okay, so that is the empty objects. I also wanted to test a double negation, so I did negation not, so negation of a negation, so we'll see how that works. And then we have test conjunctions, which is just your very simple conjunctions. And note my my style here, my semantics, no, my other one, syntax. Yeah, note my syntax. I'm just using, if I have two letters smashed together, that's a conjunction. If I have the letter V in between them, that's an OR. And then underscore stands for parentheses. So I have AB, which is A and B, which you can see is new conjunction A and B. ABC is new conjunction ABC. AX is new conjunction AX, so on and so forth. And then we have some negations here, so I'm negating AB. So I've made new negation AB, new negation ABC, and just wanted to test those out. And then the disjunctions. Okay, so like I have my conjunctions up there, I just have the appropriate disjunctions for that. So I got A or B or C, A or X, and that's all, I think, pretty self-explanatory right there. And then finally, at the end here, I just wanted to try some other Boolean expressions. So Boolean expressions that were, I guess, not exactly like, not your simple, easy Boolean expressions. Well, the first few are. So like, I basically did the not conjunctions, like not A, not B, not A or not B, and stuff like that. And then finally, when I get down here to like this one, this is a disjunction I found that you know, causes some problems, and it's in disjunctive normal form, and you know, you have to do some work to get it to conjunctive normal form. And then this is the one on Wolfram's. Like, Wolfram is a company that has like a website that does calculations on the site, and the default expression on there for conjunctive normal form is this, and it really does like expose a lot of issues and everything. So like, I ran this and I had a lot of issues in my code just by trying to do this one. So I'm glad I got to run this one, and I'll tell you what it fixed later. But this is it's a good one. It's in disjunctive normal form right now, and then it has to do some work to get to conjunctive normal form. And then I figured I'd do something on the flip side where I find a nice conjunctive normal form expression and make it do some work to get to disjunctive normal form. So yeah, that is all my expressions, everything I wanted to test really. And so when I'm doing some tests, that's all I'm really doing here. So like, if you do see this, all my literals, like for all these empties and nulls, they're going to be false. But all for my like single, like A or X or A, not X, these are going to be true. My double negatives are going to be false until they are simplified. So if you have a not something, it's not going to say it's a literal. It's going to say nope, it's not a literal. If it's a simple conjunction or disjunction, it's definitely not a literal. So really, all it's doing is checking to see if it truly is an instance of literal. And so it has to be a predication or a negated literal for that to be true. And yeah, even these complex equations are not literals. Okay. So the is clause. So a clause is basically an n-ary Boolean expression containing only literals. So it can be a conjunction or a disjunction. So I don't know. Maybe I should do the code first. Alright, yeah, we'll talk about the code first. Um, yeah, let's talk about the code. Alright, so I'm at 56. So if I talk maybe 10 minutes about the code, let's do that. So okay, this is the code for normal forms. As I said, it's made up of all static functions, and we're just going to go through each of them. So to check for is literal, all I'm doing is just seeing if the expression implements or is an instance of the literal interface. If it is, it returns true, otherwise it returns false. Okay, so a clause. A clause is basically an n-ary Boolean expression that contains only literals. So it can be a conjunction or a disjunction. So if the expression is a literal, we're just going to return true. If the expression is an n-ary Boolean expression, we're just going to go through each expression, and then we're going to check if it's a literal. If even one of them is not a literal, we're going to return false. Otherwise, we return true. And if you're not an n-ary Boolean expression, we're just going to return false. Alright, so a conjunctive clause is just like a clause, except it's a conjunction, not an n-ary Boolean expression. So we're going to do the check for is literal. If it's literal, return true, and then we check it. Hey, is it a clause? If it's a clause and it's an instance of conjunction, fine, it's a conjunctive clause. Disjunctive clause, very similar. Instead of a conjunction, we're just going to check if the clause is a disjunction instead of a conjunction, and then return true, otherwise return false. Alright, so a conjunctive normal form. A conjunctive normal form expression is a conjunction of disjunctive clauses. So we simply just check, hey, first we check is it literal. If it's a literal, then it is a conjunctive normal form. If it's a conjunction, go ahead and look through each of the arguments and see if it's a disjunctive clause. So is just disjunctive clause, we'll check whether it's like multiple phrases like A or B or C, or it'll even say, even if it's a single literal, it will return true. So because of that, as long as they're in disjunctive clause form, you go ahead and say, yeah, it's in disjunctive. But if one of them isn't in that form, you're going to return false. Alright, is DNF, is disjunctive normal form, kind of just the flip side of the conjunctive normal form. First you just check if it's a literal. If it's a literal, fine, it's in disjunctive normal form. If it's an expression, if the expression is of disjunctive form, then we go through each of the arguments to see if they're in conjunction. Is a conjunctive clause. And if none of them is, if even one argument is not a conjunctive clause, it'll return false. And then if it's not a disjunction, return false. Okay, so to convert a conjunction to conjunctive normal form, we're going to run the following code. First, we're just going to do a check. If the conjunction is null, or if it's already in conjunctive normal form, we're just going to return what it is. Just return itself. But if it's not that, we're going to do some work on it. And so what we do is we're going to start with converting it to negation normal form. And basically that just means we're going to kind of put it in straight up Boolean logic and put and move all your nots inwards. So if I just go to that function right quick, you can see it eliminates implications and equivalencies. And since we don't have that in our scope, this doesn't do anything. But then move not inwards will actually do something. It moves all the negations as far in as possible, and it does that using this recursive method right here called move not inwards. I won't go too much into it, but basically all it's doing is going through all the arguments, seeing if there's a not, and then if there is a not, if there is a negation, then if there is a negation, basically apply De Morgan's law, flip your conjunctions and disjunctions, and then negate all the arguments inside of it, and then run it again. Run it recursively. Run it for those things that you just converted. Let's see. What else am I doing here? So I'm doing that if it's a negation. If it's not a negation, it's a conjunction? Okay, so if it's a negation, do that stuff. If it's not a negation, like say it's just like a normal expression, we're going to go through each of the arguments. That's what I'm doing, yeah, getting the arguments. And if one of the arguments is a negation, go ahead and apply that. Otherwise, just add the argument, and then we create a whole new phrase here at the end. And just depending on what the expression was initially, we'll just make it that same kind of. So if it's a conjunction, make a new conjunction. If it's a disjunction, make it a new disjunction. And then you return that expression. So that's how we're doing move, not inwards. Okay. Then the other steps to make this into conjunctive normal form is to standardize the variables. We're not using existential and universal quantifiers, so we can just skip this. Same thing for Skolomai's statement and drop all universal quantifiers. If we were using these things, we'd have to implement these functions. And I'm just going to leave them here just in case we ever do expand this for any reason. But then the meat of this function is right here on distribute or over and. So what that does is basically for any or that you have, for any and that you have, you're going to split those up and then put all your or statements in it. So let me give you an example. Basically, every time you have an and, you're going to distribute all your or statements into there. So, I'll make a PowerPoint, I guess. Oh, come on. Keyboard won't work here. Whatever. I will just have to hit all apps and find PowerPoint. I think it's in Microsoft Office. PowerPoint. I don't really know. Oh, actually, Dr. Ware already has a slide on this, so I'm gonna go steal that. Where is he at? I think he's here. CSCI 6990 calendar. You talked about that in first order logic. Yeah, I think so. Here we go. Distribute or over and. So if we have an or statement of two ands, we have two and statements connected by an or. Basically, take this statement. I think I'm going to cheat when I say that. Oh, come on. Really? I need to fix that. Like, I can't type anything. Like, I'm used to like searching for the app I want to use. And I think I'll use the example I have in the code. Wherever that is. I'll use this one. Or this one. This one's pretty good. Yeesh. Except, can you paste it? Yeah. So this is really, shoot, should I do this in equation editor? I'll try. This will be parentheses, brackets, whatever. A, oh, come on. A, operator, No, not an operator. What is this? It's let's do one of these basic math. Okay, really? Oh, here we go. Big wedge, big V. So, I'm sorry. We need wedge B. And then we're going to have V. Brackets. C. V. And then brackets. X. Wedge. Y. Y. Wedge. Z. Okay. Cool. So now that I'm starting to get this, to distribute and over OR, I'll kind of zoom in too. We basically take this A and B and we break it apart. So we grab our first complex. We grab our first complex conjunction, which is, when I say complex conjunction, you can't be a literal. A clause that is not a literal, and we break it apart into individual statements. So this is what I'm doing. I believe this is what I'm doing. So I'm basically going to say A, or, so instead of that, we're going to do V. And then I'm going to take all of this, and I'm going to put that in the brackets. And then this is going to change to a wedge. And I'm just going to copy this. And then we can just kind of replace all of that. So I don't know if you can see what happened here, but basically I took this guy, split him up, A and B, and then we took the OR and just kind of put the other side of the equation here. So the cool thing about this is that we can flatten both sides a little bit. So when I say that, we can remove some brackets. So I'm going to take this out of the brackets, is what I'm trying to say. Oh gosh. There we go. I'm going to take out these extra brackets just so it's not so confusing. So okay, we got A and B, or C, or XYZ. And so here we go. I'm going to take our first complex conjunction, I'm going to split it in two, and I'm going to take the rest of the expression and OR it. So I got A or this, B or this. I'm going to simplify or flatten this expression a little bit. So now we got A or C or XYZ, and B or C or XYZ. So now we have two similar disjunctions, but now that's a little bit simpler and a little easier to clean up. So so I'll just do one more step here. And say we just split all this up. So now we have X V AC. Put that in brackets. Where's the brackets? Here it is. Brackets, wedge, and then we'll just copy this like 2 times, I think. XYZ, I believe. So I think now I can just take this and replace these with the B's. Yeah. Okay, so now all I did was take this XYZ. This is my first complex conjunction in this little parentheses, and I'm gonna break that up, and I'm gonna say X or A or C, and Y or A or C, and basically break that up a little bit, and then do the same thing here, and then finally we have something we can flatten to a completely conjunctive normal form. So let's see. So this is in conjunctive normal form, and it should be fine. But I'm going to take it a step further because I wanted to implement some like simplifiers, some things that cleaned it up a little bit, because we can see that let's see, like XAC, YAC, ZAC. Oh, I don't know. This might be it for this. Anyway, I'm gonna just paste this onto a slide. I thought I had PowerPoint up. Oh well. Let's bring that back up. Microsoft Office, PowerPoint. Layout. Let's just do some content. I'm hoping it just, yeah, I guess I gotta bring it down just a smidge. Okay. Distribution of or, over, and. So we have A, B, C, X, Y, Z, and here's an expression. So we want to make this into, right now it's in disjunctive normal form, and we want to make it into conjunctive normal form. So to do that, we find our first complex conjunction. So if we see, like, if we're going through our expressions here, we already know it's in disjunctive normal form, or we don't. I mean, it doesn't matter. We just know that, hey, this is a disjunction. So first we determine whether it's a conjunction or a disjunction. So right now we know, hey, this is a disjunction. Great. Now we're going to go through this. We're going to make sure it's not a disjunctive clause. and we're going to make sure it's not in conjunctive normal form. So that's the two checks I'm doing before I even start doing any work. Alright, so let's see. Is this a clause? Is this already in conjunctive normal form? So, I won't even worry about this. So these are the first two things I check, and from the expression I have here, it's not. It's not. It just simply isn't. So because it isn't, we can go ahead and go on with the calculation. So what is the calculation? So what we do is in my form in my function distribute or over and, what we do first is we check, is it a clause? Is it conjunctional form? If it's not, then you take your first complex conjunction, which we'll just kind of iterate through this. Sorry, is this perform action on this if disjunction, else perform action on arguments if conjunction. So this is kind of the, alright, so this is the meat of my code, so I figured I'd just make a quick slide on this. We have a formula, we check, is it a clause? If it's not, then we do work on it. If it is, then we can just return the clause as is, because there's no work to be done. Is it in conjunctive normal form already? If it's in disjunctive normal form, you're already guaranteed that it is just a conjunction of disjunctive literals, so or disjunctive clauses. So you already know you already done your work. But alright, if not, then we're going to perform some actions. So if it's a disjunction, we're going to do some actions. If it's a conjunction, we're just going to do the actions on each of its children. So this is how it will work. Oh, we'll basically run this else run this function on arguments on conjunction of conjunction. Alright, so this is a disjunction, so we're just going to perform some actions to it. So the action we're going to perform is we're going to take the complex conjunction, the first complex conjunction, and we're going to split it up. So right now it's just two literals, but it doesn't have to be two literals, it could be anything. So we split it up, and then we're going to disjunct everything else, all the other expressions to it. So what I mean by that is, like, we can just see it here visually. We had A and B, we split that up, and then we took the entire other side of the expression and we ORed it. So we said, hey, A or the entire other side of the expression, and then we said and B or the other side of the expression. So this is equivalent to this. Great. And so now we see we have some ors and brackets, and what we realize is we can kind of flatten this down to a more manageable disjunction. So there is a flattened function already, so we just call that. And now we are here in this nice flatter version of the above equation. And we still see, hey, we still have some conjunctions in our disjunctions. So what we'll do here is we just run it again for this side of the equation, run it again for that side of the equation. So this is a conjunction. If we ran this through the distribution of this function again, which we are, we're going to perform it on all the arguments, not on you can't run it over the entire thing, because your goal is basically to get this in conjunctive normal form. So okay, we run it for this, and basically we're going to split up x, y, and z, because that is our first like complex conjunction. And now we have a whole bunch of phrases or terms, clauses. And this is actually now narrowed down. So all we have to do is flatten this out, and we have one long string of disjunctive clauses, a conjunction of disjunctive clauses. So yeah, and then we're finished. Poof, done. So that is the distribution of or over and. So if I go back to my code, if I go here, and if I go to distribution of or over and, I can just kind of show you what I'm doing. Here's my checks. If it's a disjunction, you're gonna get the first complex conjunction, then you're gonna get the other side of the expression, and then you're gonna make a new disjunction with each of those arguments of the complex arguments, and then you're gonna just run this. You're gonna run this again through each of the arguments, so like the left side and the right side, and then you're gonna run it one more time with your whole conjunction, just to see if everything finished up, and then you're done. And I'm always using the simplify because I always want to flatten that expression down to as simple as it can get. And then if it's a conjunction, go ahead and just go for each of the children. Otherwise, return the expression because it's not a conjunction or disjunction. And over or is just the opposite of or over and. Great, so that is the conjunctive normal form. Now, I know I didn't give you an example of this, but there are times where you're going to get the same values multiple times throughout your conjunction, and some of them, it's going to be duplication. So what I did was I looked up some methods to like simplify the conjunctive normal form into something a little more manageable. So instead of this really long string of conjunctions, it'll simplify it down a little bit. So the first thing we do is just remove duplicates. If you see the exact same argument multiple times within conjunctive normal form, just get it out of there. Remove tautologies. So this basically just says, hey, if you have A and B, or A and not B, that's logically equivalent to A. And just so you can kind of wrap your head around it, basically you're saying, hey, if I can have A and B, so I can have both of these true, or I still gotta have A, but I don't have to have B. So either way, I'm cool. So give me A. And vice versa, if you have A or B and A or not B, you're just saying, hey, I gotta have one of these, A or B, but look, I also have to have A or not B. So that means I'll never really have this B part down. I have to have this A for it to work. So anyway, that's a tautology. Back to where I was. Nope. Where am I? Here we go. Terms that cancel each other out. So here's some terms that cancel each other out. Oh, that was that. What's a tautology? Oh, tautology was this one. Oh, tautology is if you have yourself and your negated literal in the same clause, that's a tautology. So if I said A and B and C and not C. Alright, if I said A and B and C or not C, That's always going to just, C or not C is always going to resolve to true. So basically you're just saying A and B. If you have A and B and C, I'm sorry, A or B or C and not C, that's C and not C is always going to resolve to false. So basically you can get rid of that in a disjunctive clause. What else? Supersets. So if you have AB or ABC, you only need AB, because once you have AB, you don't need to worry about ABC. So that's equivalent to AB. And the same thing with the ANDs. You have A or B and A or B or C. If you gotta have both of them true, you really just need to get A or B. So that's supersets. And that is it. And some helper functions at the bottom. And that's how I handled getting conjunctive normal form. And so now it returns a nice simplified version of conjunctive normal form. Now, disjunctive normal form is just the opposite of conjunctive normal form. It uses a lot of the same functions. So first I'm just checking, hey, is it disjunction or if it's null? And then I do all these same things at the top. And here's the big difference. I'm going to distribute AND over OR instead of OR over AND. And now I got disjunctive normal form. But if I wanted to simplify it, I can use all these same simplifiers. And then I can return that as disjunctive normal form. And then if I'm trying to convert a conjunctive normal form from a disjunction, all I got to do is just wrap it around a conjunction wrapper and just go ahead and do it. And I went ahead and simplified it just in case it wasn't simplified earlier. And then the conjunction, if you try to change a distributed normal form from a conjunction to a disjunction, I just put a disjunction wrapper and just let my function roll on it. And that is it. That is the gist of my code. Cool. So that's pretty good. Let's see. Any cool designs that I can use? Thought I could like browse online or something. Yep, like this the best I guess so far. Let's go ahead and make this a little bigger. Can I bold it too? Yeah, awesome. Alright, cool. So I'm good with that. I might try to just look over this one more time, make sure my laptop's all set up for tomorrow, and I'll be good to go. Yep, I'm cool. Let's export this to a PDF. Should you not mind. Nice. Alright. Good deal. Got that, got that. Code looks good. Did I make any changes to the code? I don't remember. Yeah, I think I did. Let me go to Java view. If I play this, it all tests out. Great. Package Explorer. I'm just going to go to team, commit. Guess I didn't have Thomas last time. Well, this time I do. Alright, so what did I do here? Yeah, that's okay. Okay, yeah, check the is null thing. That's good. Got some empty objects, and I started testing those empty objects. Alright, I feel pretty good with those two things. I am... Alright, and let's go ahead and do that. Okay. I am good, I think. That's it. Alright. See you guys later. That was good.